Welcome to our fourth video for vision science research. In this video, we'll learn how to use keywords and subject terms to create search strings using Boolean logic, quotation marks, and asterisks when appropriate. The strategies we'll cover in this video can be used in nearly every database. So while interfaces vary between databases, you can use these same general strategies in all of them. One thing to consider when you're searching different databases is that you can usually switch between basic and advanced search boxes. The advanced search boxes may show you additional search features, so you might try to use them to see if they could be helpful. After coming up with your keywords, now our goal is to enter our keywords into the search box in a logical way so that they'll bring us relevant search results. Databases use Boolean logic, where you can use and or and not to connect your search terms, and you can use parentheses to group them. So let's talk about how to do this. When you connect two search terms with and, you're asking the database to bring you results related to both of those search terms. This should focus your search results and bring you fewer search results because they need to be related to both of those search terms. In this example, you can see we had about 27,000 search results when we searched for myopia alone, but we narrowed it down to 468 results when we added and atropine. You want to connect unique concepts with and when you want search results that have both of those concepts. In our example, we want articles that talk about myopia and atropine. If we search for those terms connected by and, our results should be related to both of those terms. So and is meant to connect unique concepts. A simple example of this is if you wanted to find coffee and croissants. You could search for coffee and croissants and find results related to both. When you connect your search terms with or, you're asking the database to bring you results that have either one or the other of the search terms or both of the search terms. This brings you more results. Use or to connect synonyms or similar search terms. This is to make sure you aren't missing relevant articles because you used one search term for a relevant article, but a relevant article uses a different word to describe your topic. In our example, we try searching for 0.05 atropine and get 2,440 results. Then we add or 0.01 atropine and get 3,755 results. Basically, in this case, we're asking the database to bring us results related to either atropine and the number 0.01 or 0.05 for both. So when we do this, we increase our search results. A very simple example of when you might use this would be if you were searching the word coffee, but you would also be happy if you found something about espresso. So you could search for coffee or espresso and find results related to either one or both. You can use not to exclude search terms that you place to the right of not. So in our example, we searched for children and found nearly 3 million search results. Then we added not adults and the number was reduced to nearly 2 million. I honestly hardly ever use not. The thing about it is that you have to be careful because you might accidentally exclude relevant search results when you use it. I find that I usually get relevant search results by using and or only, so I don't really recommend using it. So how do we put it all together? Synonyms with or and put them in parentheses. In our example, we put 0.05 atropine and or 0.01 atropine in parentheses. Then connect your unique concepts or groups of synonyms with and. So we have three unique concepts here: children, myopia, and atropine. So our search string, when we put it all together, looks like child and myopia and in parentheses 0.05 atropine or 0.01 atropine. This should bring us search results that are about all three concepts: myopia, children, and either 0.01% atropine or 0.05% atropine. The next thing that you can do is add quotation marks around logical word pairings when you want to find search results with those exact words in that exact order. When you put quotation marks around two or more words, it brings search results that have those words in that exact order and excludes other results. In the example below, you'll see how when I searched for axial lengthening without quotation marks, I found results that had those words, but not necessarily in that exact order, and so were not actually about axial lengthening. When I searched with quotation marks around those words, I found search results about axial lengthening. However, sometimes quotation marks can be too limiting. For example, some relevant articles might call it axial elongation or something else. So you would miss those if you only searched for axial lengthening in quotes. What I do is try my searches with and without the quotation marks for different terms and see which way brings up the most relevant results. The last thing you can do is add an asterisk to the end of a word to bring up results with any version of the word after that asterisk. So if I write child asterisk, I would get child or any word that started with the letters CHILD. So I'd get children or childhood in addition to child. It's not usually necessary to do this, but sometimes it can be useful, so keep it in mind. So how do we put it together in a search string? Select from the keywords and mesh terms and put them logically into a Boolean search string. Try a search string and see how relevant the results are and keep changing it until you think you found relevant results. Don't be afraid to remove or add unique concepts. Sometimes if you have too many unique concepts connected by and, you get too few search results. You can see I have 4 different search strings here. I kept changing them by removing or adding in parts until I felt like the results were kind of relevant. We'll start with a simple search string, child and myopia and atropine. This brings us 385 search results. Now we want to click Advanced to see how PubMed is interpreting our search string. It's searching using different forms of the word child as keywords and also searching child as a mesh term. We remember that the child mesh term brings us search results for children ages 6 to 12, but our population is children age 5. So we want to make sure it includes child preschool, the mesh term, which includes children ages 2 to 5. So we'll do that in our next search string. We also see it's searching for myopia as a mesh term and as a keyword, and also for atropine and hyoscyamine as mesh terms, keywords, and for hyoscyamine as a supplementary concept. If we look it up, we see it's a drug related to atropine, and so this should be okay. When we look at our search results, they look to be about myopia control and atropine, but we'll see how we can improve our search string. It's good that PubMed is using both keywords and mesh terms, but why? Why is it good that it's using both? This is because not all articles in PubMed are indexed with mesh terms, so they can only be found with a keyword search. For example, it takes a little time, up to a couple of months, for mesh terms to be assigned to newer articles in PubMed. So if we just searched using mesh terms, we would miss those articles. So in summary, it's good to use both. In our next search string, we'll try child as a keyword and child preschool and the child preschool mesh term to ensure we're including our population. Then we'll search for myopia and therapy as keywords, or myopia / therapy as a mesh term, to see if we can focus our search results on myopia and therapy. Our search string is child or child, preschool, the mesh term, and myopia and therapy, or myopia / therapy, the mesh term, and atropine. This brings us 279 results. We can see that it's searching for the child mesh term, the child preschool mesh term, and different forms of the word child as a keyword. This seems fine. When we have myopia and therapy as keywords, the mesh terms and myopia therapy / therapy as a mesh term, this also seems fine. Our search results look a little bit more on topic as well. Now let's add 0.05 or 0.01. Theoretically, when adding this to our search string, we should see results related to 0.05 or 0.01% atropine. Our search string is child or child preschool, the mesh term, and myopia and therapy, or myopia / therapy, the mesh term, and atropine and 0.01 or 0.05. Now we have 138 search results and they look quite relevant. The 0.01 and 0.05 are being searched as keywords. We'll try one more search string. We'll try child or child preschool, the mesh term, and myopia and atropine and 0.05 or 0.01. With this one, we removed the therapy part since we have the atropine and 0.05 and 0.01, which are pretty specific. So we want to remove the therapy part just to make sure it's not excluding relevant results. Now we have 196 results, which looks really good, and the results look quite relevant.